what I'm going to start. So I believe you are seeing my screen. Let me. Yeah. Okay. So just wait there, and I will. I gave one problem like this in 2D equilibrium. This is just for long-term planning. Um, See, this problem you can solve it by taking um, the free body diagram like this, and considering the weight force 10 kilonewton acting here, and then the tension T acting over there, and the reaction forces AX and AY, unknown reactions there. And we are asked to calculate, so the AX, AY, and the tension in this one. So looking at the geometry, we can take the we can use the equations sigma f x equal to 0, sigma f y equal to 0, and sigma m a equal to 0 to solve for the unknown quantities. So use the geometry and solve, and I'll tell you the answers that you get are AX is 17.77 kilonewton, and AY you will get as 6.37 kilonewton, and the tension T as equal to 19.61 kilonewton. So you can do this as homework. Definitely make sure you do that. Take the proper geometry here. What I mean is you need to take those distances, and there is also some distance given here. Please be careful about that, and resolve this into a vertical component and a horizontal component, because you are given with that angle 25 degrees there, and you can solve this problem as a two-dimensional equilibrium problem. But in the class, I told you if there are only three forces acting on any member, and if the member is in equilibrium, there is one more rule to be satisfied. That rule is the three forces, when you extend their lines, they should meet at one particular point, and that point is the point of concurrence. Now, here you may say there are actually four forces, which are AX, AY, 10 kilonewton, and T. But in reality, AX and AY can be taken as a combined force A if you combine it. Now, what it means is, now you can see that if you extend the line of action of this 10 and the T, which are given to be acting in that line, they meet at that point. Our total A reaction at A, if you call it as A, when you extend the line of action, it will pass through that. That is the point of concurrency. And not only that, when three forces are acting on a body, they form a concurrent force system like this. And if you draw a triangle, it forms a closed triangle. And this triangle you can form the way you like it. For example, let's say the 10 kilonewton force, say it is acting vertically downwards. So we can put it like this. So I'm drawing the force triangle, 10 kilonewton force, which is acting vertically downwards. And then this tension force T, we know it acts something like this. And it makes a 25 degrees angle with the horizontal, because here it is given as 25 degrees. So this is 25 degrees. If this is 25, this is 90 minus 25, which is, what is 90 minus 25? 75 degrees. And the third force, what it should do is, it should form a closed triangle like this. This is our total reaction A, and this is the 10 kilonewton force, and this is our tension T. 65. 90 minus 25 is 65. Whatever you say, sir. 65 degrees. Now, in a triangle, if you know three, magnitudes, so then we can solve for the unknown quantities. So the three magnitudes here are, for example, this dimension is given as, we know this distance, we can calculate it from the geometry. And from the geometry, we can also estimate what this height is. So if you know those two, you can calculate what is the angle at which the reaction A is coming. So if you know that angle, so that is the angle it is making with the horizontal theta, then we will know this angle. If you know this angle, and this angle, we can use the sine rule and the cosine rule appropriately and solve for A and T directly. I want you to do this as a homework too. And if you don't get it, I will solve this in the tutorial on Friday. So if you have a three-force member, you can always consider this law and find out the point of concurrency. And even if some distances are not given, so you don't need to worry about all those distances in that case. You can just straight away get the answer. So I want you to try both methods and let me know on Friday in the tutorial. I will complete that solution in Friday. Okay. Now I will see if there are any questions. Okay. I'll go to the next problem. This is a truss problem I brought in. I will also come back to this truss problem towards the end because I want to complete the other two topics first. I will come back to this later on. So first what I will do is In the last class, in the last online session, if you remember, I solved up to that problem, but I stopped it there. So I will continue doing that now. So this is a typical problem for solving the centroids. Carefully follow this and see what I'm doing. Locate the x bar and y bar of the centroid of the shaded area. So we can roughly estimate the centroid is somewhere over here. And so what we want is what are its x and y coordinates. To get that, we need to first take a strip. Should we go with a vertical strip or a horizontal strip? So here, the shaded area is enclosed between two curves. So both strips are equally good or equally bad. So I will take a vertical strip like this. And let's say that is considered at a distance x from the y-axis. And we need to take this height, which we will call as y1, and this height we will call as y2. And the width of the strip is parallel to x, so dx. As you can see, the area, so the upper curve is y squared equal to 4x. So that is this curve. If you call that as curve 1, so this is our curve 1 is equal to, let me write it quickly. Y squared equal to 4x is what is given, but we want to write it as something y equal to what? So therefore y equal to 2 root x, or we can write that is our y1. So let me write it as y1 equal to 2 x to the power half to make it clear. So our y1 values will follow that curve on the top, which is that. And our curve 2 is y equal to 1 over 4 x squared. So we can say our y2 is following that curve 1 over 4 x squared straight away. Now the area dA, let me write it here. dA, the area of the elemental strip is its length, which is y1 minus y2 times dx. But we can replace y1 and y2 with the appropriate quantities, which are 2x to the power half minus 1 over 4 x squared dx. And total area A is equal to integral dA, which is integral. We need to move that strip from x equal to 0 to x equal to that limit, which is 4, to cover the whole area. So 0 to 4, 2 to the power x power half minus 1 over 4 x squared dx. So that will be equal to 2 times x to the power half plus 1 is 3 over 2. and 3 over 2 divided by 3 over 2, it becomes times 2 over 3 times x to the power 3 over 2 minus 1 over 4 x cubed over 3. So which is x cubed over 3 times 4, 12, between limit 0 and 4. Substitute the upper limit. This becomes 2 times 2 over 3 times 4 to the power 3 over 2 minus 4 cubed over 12. So from that, the area A is equal to 5.3333 meters square. So that is the area of the curve that is identified. Now let us create a separation here. I'm calculating the x bar because it's easy to calculate x bar using a vertical strip. So the total movement A times x bar is equal to sum of the moment of the strips dA times x. So dA is integral 0 to 4 y1 minus y2 times this x and a dx, which is integral 0 to 4 y1 is 2x to the power half minus 1 over 4 x squared times x dx, which is equal to integral 0 to the power 4 2x to the power half times x is 2x to the power 3 over 2 minus 1 over 4 x squared times x is x cubed dx, which is equal to 2 times x to the power 3 over 2 dx is 3 over 2 plus 1 divided by 3 over 2 plus 1, which is 5 over 2 divided by 5 over 2. It becomes 2 over 5 times to the power 5 over 2 minus 1 over 4 times x to the power 4 divided by 4 between limits 0 and 4. So that is equal to 2 times 2 over 3 times 4 to the power 5 over 2 minus 1 over 4 times 4 to the power 4 divided by 4, which will simplify to 9.6. So from this, x bar equal to 1 over a, which is 9.6 divided by a is 5.3333. Therefore, x bar is equal to 1.8 meter. So where are we now? 2 by 5, okay. For that. Okay, let me see where what's happening here. Yep. Yep, 2 over 5 is corrected, and you always take the top curve as y1. It's up to you. If you call that as y2 and the bottom as y1, it becomes y2 minus y1. It's your choice. All right, let's proceed and calculate Now you will always get a positive value because the centroid is not on the negative side. Okay, let me do y bar here. So we are still having the same strip and all the conditions remain the same. I'm just transferring the data from the previous page to this page, which is this one. And we have that height is referred to as y1, and this height is referred to as y2, and this width is dx, and the strip is considered at a distance x. Now we want to take the sum of the moments. We already have the area of the curve is 5.3333 meters square. We already got it. So now we want to take the sum of the moments about the y-axis, so that a times y bar equal to dA times, what we should do now in the calculation of centroid is we need to take the center of the strip and write its distance from the moment axis. So let's call it as y bar. And I have shown you a number of times earlier also that y bar is equal to, first the length of the strip is y1 minus y2. Half of that length is 2, which is the distance from here to here. But this extra distance y2 should be added to get the total y. So plus y2, which is equal to y1 minus y2 plus 2y2 divided by 2. So the distance becomes y1 plus y2 over 2. That is the only thing. So therefore, dA times the distance of the center from the x-axis is y1 plus y2 over 2. What I'm doing here, I'm taking the moment of the strip area about the x-axis. Moment of area is nothing but the area times the distance of the center of that area from the axis. We can take moments like this for calculation of centroids. So, but dA is already we found is y1 minus y2 times dx, and this extra y1 plus y2 over 2 is there. So this becomes integral half can be kicked out, y1 minus y2 times y1 plus y2 times dx, but that is equal to half integral 0 to 4 y1 squared minus y2 squared, because a plus b times a minus b is a squared minus b squared dx. Now 1 over 2 integral 0 to 4 y1 squared is 2 to the power no, y squared is equal to 4x. So y1 squared is basically 4x. And y2 is equal to 1 over 4x squared. So y2 squared is minus x to the power 4 over 16 dx. So which is equal to half integral 4x is 4 times x squared over 2 becomes 2x squared minus x to the power 5 over 5 times 16 is 80, 0 to 4. So which is equal to half 2 times 4 square minus 4 to the power 5 divided by 80. So this is a times y bar equal to 9.6. Therefore, y bar is equal to 9.6 divided by a, which is 5.3333. Therefore, y bar is equal to 1.8 meters. So that is the solution. Let me put it in full view. Okay. Now let me see what's happening around the world. Any questions? We have 134 students today. Okay. Now let me go to the next problem. If you solve this problem, if you are forced to solve this problem with a horizontal axis, so what will happen? So you can try that at home and see if you're getting the same answer or not. Let me go to the next one. The gravity wall is made of concrete. Determine the location x bar, y bar of the center of gravity G for the wall. So we need to consider standard shapes to define the final shape. As you can see, the final shape of the dam is enclosed within those lines. That is the actual shape we are talking about. All right. To reach there, what we need to do is we need to divide this into a number of standard areas. I'm taking them like this. For example, if I enclose this whole thing as one rectangular area, you can do it in a number of ways. I'm doing it one way. You can do it other ways and see. So I will take the bottom one as A1. This full rectangle, which I will put in a, let's say, black color. I will call this area as A2. We will add the, we will find the centroid of these two areas as standard shapes, but then we need to subtract this part of the triangle, which is not there. This triangular area from here, we need to consider that as a negative area, and also this triangular area we need to subtract from there. So then we can get the moment, the centroid of the compound area from both x and y axis. So for this, I wanted you to do it like a table. So what we can do is, I will write it here if it is possible. I'll write it here. Say the area A1, A2, A3, and A4. The bottom strip area, which is this area, it's equal to the base length is 0.6 plus 2.4 plus 0.6, which is 3.6 times the height is 0.4, which will give us an area of 1.44. So leave it like that. Then the bigger A2 area is the base length is 2.4 plus 0.6, which is 3. So 3.0 times the height is 3 meters, so which is equal to 9. And area 3 is a triangle with whose length is, if you see the diagram here, this total length from here to here is 3 meters, and you subtract 1.2 from that, which will leave you with 1.8 meters for this length, 1.8 there. So the triangle area is half base times height. The height of the triangle is 3, so which will give us, but this is non-existent triangle, so we should take it as a negative 1, so minus 2.7. And similarly, this triangle, its base is 0.6, its height is 3, so we will write it as minus half times 0.4, 0.6 times 3, which is equal to minus 0.9. So the area part is done. So then we need to write the x bar, x distances and y distances of the centroids of these areas, one after the other. For example, for the first one, the center is here. So it's with reference to the given coordinate system, the x coordinate of that is the total length is 3.6 divided by 2, which is 1.8, and the y coordinate will be half of that 0.4, which is 0.2, which is straightforward and simple. And for the bigger rectangle, this one, for that rectangle, the center is at 1.5 from here, and at half of this 3 meters, because this total length is 3 meters, so this is 1.5. So its x coordinate will be 1.5 plus 0.6, and the y coordinate will be 1.5 plus 0.4. I will erase these things now to avoid confusion. So the x and y coordinates will become 2.1 and 1.9. Then come to this triangle. For this triangle, the centroid is here. It will be, this height will be 2/3 of the total height. The total height is 3 meters. So 2/3 of 3 is 2 meters. But from the base, it becomes another 0.4 meters extra. So the y coordinate of that is 2.4. And the x coordinate will be, from this base, it will be at 1/3 the height. This height is 1.8. So 1/3 of 1.8 is 0.6. but there is an extra zero point 0.6 here. So 0.6 plus zero point 0.6, it is 1.2. And I will erase these things here just in case. And I'm coming to the last triangle, which is here, the centroid. And its distance from here to here, this is 1/3 that height, which means 1 meter. But there is 1.4, so 1 plus 0.4, the y-coordinate of that is 1.4. And the x-coordinate will be, if you can see here, so it will be 1/3 of this 0.6 from this end, or 2/3 of 0.6 from here to here. So this is equal to 2/3 of this length 0.6, which is equal to 0.2 times 2.4. So this extra distance is 0.4 plus 2.4, so 2.8 plus 0.6, so 2.8 plus 0.6, it is 3.4. So its x-coordinate will be 3.4. Delete everything now to make it clear again, but I will only leave what we did at the start. That is the area and I am deleting this part of the area and this part of the area. So even if you did not understand readily some of these distances, sit down on the solution for some time and figure out how these x and y values are identified. And the rest is simple. A times x and a times y. So they will become 2.592, 0.288, 18.90, 17.1, minus 3.2, minus 6.8, 748. So I'm not very happy with the way I wrote this. Meeting. So if you add all of them, sigma AX is equal to 15.192. Sigma AY equal to 9.648. Therefore, x bar equal to Let me see. Miss Charlotte Chen, what is the problem? Mr. Michael Agno, is it possible to solve this question with integrals? Yeah, if you want to try, you try it. And in the meantime, if you die, don't ask us. Where is 6.484 from? What is 6.84? Where is it? 6.84. Added all areas, yeah? Yeah. Oh, yeah. Added all areas. I need to put that here. So some of the areas. The areas that are to be subtracted should be taken as negative, which are not there. Any other question? Okay, I'm going to the next question, no matter what. So I have almost covered everything that is needed for you, and it is up to you to practice these problems now in the calculation of centroids. Now let me do this one. Determine the moment of inertia of the shaded area as shown in figure 3 about the y-axis. Now, about the y-axis, if you can take a vertical strip, that will make life easier. But if I take a vertical strip for this area, it creates a problem because you can't sweep it from the left hand to the right hand. From here to here, it is controlled by that curve and this line. That's fine. But from this point onwards, the x-axis is lost and it is controlled by that upper curve and that lower curve. So it is changing integration. So you need to consider that as two areas and all that, and then two types of integrals. It becomes a hazard. So a vertical strip is now not a good thing here. Horizontal strip, yes. If we take a horizontal strip like this, for example, then we need to take this one, for example, as it is now measured parallel to the x, so call it as x1. Let me put it in black color so that it is better looking. One, and the other length, this one, is x2. Now the width of the strip is dy. First, our x1 curve, this is, let's say, our x2 curve, and this is our x1 curve. So the equation for curve 1 is, it is a straight line, The equation of a straight line is not given, so we need to make it up. So y equal to mx plus c is the equation, where m is the slope of the line. The slope of this line, which is inclined like this, is this height, this divided by this, and it is positive because it is inclined to the right. So therefore, y equal to the slope is, the height is 4 divided by 2 times x plus c, or the y is equal to 2x plus c is equation, and c is a constant. We need to pick that out also. So for that, we need to use a non-boundary condition. The non-boundary condition is at x equal to 2, y is 0 for this one. So therefore, substitute this 0 equal to 2 times x equal to 2 plus c. Therefore, c equal to minus 4. And so the equation of that curve is 2x minus 4. That is curve 1. But we want to write it as x equal to something, because our strip is parallel to the x-axis. Our lengths are in x1 and x2. So therefore, rewrite this as 2x equal to y. Take that 4 to that other side, y plus 4. Therefore, x equal to half y plus 4 over 2, which is 2. That is actually how our x1 is varying, because we call this length as x1. If you see that, that is x1. Okay. Our curve 2 is the top curve. The equation given is x equal to k y squared. It's in good form. It's x equal to a function of y. That's what we want. But k is a constant. When we know the conditions, we need to keep that out. As you can see in that, when x equal to 4, our y value is equal to 4, 2. You substitute that. Therefore, 4 equal to k times 4 squared. So from this, k is equal to 1 over 4. So the given equation is x equal to 1 over 4 y squared. This is our x2 actually. We call that as x2. Now, the moment of inertia of this strip area about the y-axis, remember, we cannot write it as dA times half of y squared, because all the points are not at the same distance from the y-axis. It is perpendicular to the y-axis. So each point is at different distances from the y-axis. In such case, I told you in the class, you need to use the standard equation for the moment of inertia of a rectangular shape on an axis passing through the base. You can refer to the formula sheet, but the formula sheet tells you the moment of inertia of a rectangular area which is having a base width of v and a height, say d, about an axis passing through its base, let's say x-axis, ix is equal to 1/3 b times dq. This is our formula sheet. If you have it in front of you, you refer to it. Otherwise, you will get it in the exam. So if you want to apply that to this strip, what you can do is you can take this as the x-axis. So first write the moment of inertia of the whole strip, which is, let's say dix, the moment of inertia of this small strip about the y-axis is 1/3. This is the axis. So the width of the strip is dB is equal to dy times the whole length of the strip is x1 cube minus we need to remove this area which is non-existent. So minus 1/3 dy times x2 cube. That is how we do it. This is the most critical step. We're just using the formula sheet here. And let me see if anyone has any question here. Okay. Now, this is from the formula sheet and we put it in our required format. So, but that is equal to 1/3. X1 is this thing. So let us substitute that, which is y/2 plus 2 q minus x2 is y²/4. y²/4 whole cube is y⁴ cube, which is 64. And I am taking 1/3 common and dy commonly outside. So I just substituted what is x1 equal to and what is x2 equal to from here. But in the process, simplified that expression. This is dix, which is the moment of inertia of the small strip about the y-axis, sorry, diy. We are calculating it on the y-axis. So therefore, the total moment of inertia about the y-axis is equal to integral diy as you move that strip from y equal to, this strip is considered at an arbitrary height y from here. And so diy as y is varied from 0 to 4, which is equal to 1/3 integral 0 to 4 y/2 plus 2 whole cube minus y⁴ dy. Now I will expand this one. This is a plus b whole cube. A plus b whole cube if you don't know, you will write it as a plus b whole square times a plus b if you don't remember. But a plus b whole squared, everybody knows, a squared plus 2ab plus b squared times a plus b. First multiply with a cube plus 2a squared b plus ab squared. Then multiply with b plus a squared b plus 2ab squared plus b cubed. When you simplify it, it becomes a cube plus 2 3a squared b plus 3a b squared plus b cubed. So you just apply that here. 1 over 3 integral 0 to 4 a cube is y over 2 whole cube, y cubed over 2 cubed is I think 8 plus 3 times y squared b, which is 3 times a squared, y squared over 4 times 2 plus 3a y over 2 b squared, 2 squared plus 2 cube minus y to the power 6 over 64 dy. So this is equal to 1 over 3 integral 0 to 4 y cubed dy is y to the power 4 over 4 times 8, 32 plus this one simplifies to 3 over 2 y squared. Okay, so it becomes 3 times y cubed over 3 times 4 times 2. The 3 y cubed over 3 and this 3 gets cancelled. So y cubed over this 4 gets cancelled by 2 times with the 2. It reduces to y cubed over 2 plus 3 times 2 squared over 2 is 3 times 2, 6. 6y dy integral is 6y squared over 2. So it reduces to 3y squared plus 2 cubed is 8. Integral 8 dy is integral 8y minus y power 6 integral is y power 7 over 7. So y power 7 divided by 7 times 64 is 448. This is the integral is already done. Between limits 0 and 4. Substitute y equal to 4, 1 over 4, 4 to the power 4 over 32 plus 4 cubed over 2 plus 3 times 4 squared plus 8 times 4 minus 4 power 7 divided by 448. Sorry, this is 1 over 3. Therefore, I y is equal to 27.8. Okay, let me see. Any question? We have 137 students. Okay, please zoom in. Yep, you can take the whole parabola and subtract the triangle. So what it is what? Let us do it also. Let me do it that way and show you how the whole thing is working. Let's do it that way. Okay, I'm doing it in a second way, but not all the time it's going to work. Be careful. So where is it? Okay, let's do it. I'm doing it in a second way, using the second method. So for that, what I need to do is I just copy this and paste it. Can you see the action? Okay. And because I can't see what you actually see, just visible. All right, let us do it in a slightly different way. Okay, what we want to do is take the whole of this as one area, and then remove the triangular portion, moment of inertia from it, and then let us try and do that now. So for the whole area now, you can take, because um, give me a second. I will do it for, yeah, okay. Now that we are taking a full area, we can use either vertical strip or horizontal strip. I will take a vertical strip like this for the whole area. So the whole area we call as A1, and this we call as A2. So for area 1, so dx, and the height of this is, let's say, y, and y is equal to, x is equal to, as we already calculated earlier, that the equation is x equal to 1 over 4 y squared, or y is equal to 4x, and y is equal to 2x to the power half. Because we are taking this at an arbitrary distance, say x, and this is a vertical strip, so all the points are at the same distance. So di y is equal to the area times x squared. We can write like that because it's parallel to the y-axis. But the area is y times dx, but and x squared. Therefore, diy is equal to, y is 2x to the power half times x squared and dx, which is equal to 2 times x to the power half plus 2 is 3 over 2 dx, that is di 1. So therefore, the moment of inertia, whole of it about the y-axis for the whole area is integral dy, which is equal to 2 times integral x to the power 3 over 2 dx, as the strip is varied from, now we took a vertical strip, so it's equal to 0 to 4. So that is equal to 2 times x to the power 5 over 2 divided by 5 over 2, which is 2 over 5, x to the power 5 over 2, 0 to 4, which is 2 times 2 over 5 times 4 times 4 to the power 5 over 2. So we don't have the answer. Please calculate this. Two more. Y is equal to, this is for the whole area, let us say IY1. Four, that's equal to 25.6. That is for the whole area. But now we need to subtract the moment of inertia of that triangle about the y-axis. So how do we get that? So we need to use the parallel axis theorem. For example, the moment of inertia of the triangle, this triangle, about an axis passing through the centroid and parallel to the base, this base, we can calculate this. I will pull out from the formula sheet. If you have the formula sheet, you refer to it. So it's too clumsy for me to move to different screens with all this setup, so I'm not doing that. So for a triangle like this, if you have an axis passing through the centroid and parallel to the base x bar, so then the moment of inertia about that x bar, I x bar, is given as 1 over 36 times b h cube, where b is this distance and h is this distance. So we can use that here. How do we use this? So about the parallel axis is area 2. First, I y2 is equal to I y2 bar, which is the moment of inertia about this axis, plus area 2 times it's a distance from the parallel distance between the two axes squared, and that parallel distance is this distance. That is the distance between our y-axis and this. So we call that as d2. We will find what that d2 is very shortly. But let me first write what is IY2. IY2 according to this equation is 1 over 36 times the base. The base now is this length, because that is the parallel base, which is nothing but 4 in our case. 4 times The height is this distance, which is 2. So BH cube, which is 2 cube, plus half area of the triangle is half base, which is 4 times height, which is 2 times this d2 is, as you know, from the apex, the centroid is at a distance of 2/3 h. Here, h is 2 meters, and 2/3 h is 2 over 3 times 2, which is 4 over 3. And there is an extra distance, but that is the distance from here to here. And this distance is 2, and so it becomes 2 plus 2/3 of 2, which is 4 over 3. That is the distance d2. This distance, this is nothing but d2. I'm writing that for your reference. Simplify this and find out what is I y2. Humor, can you do this calculation without making mistake, please? Is it correct? 6 point? Let's hope this is correct. So therefore the net IY must be equal to IY1 minus IY2, which is 25.6 minus 6.32. How much is this, sir? Is it the same as what we got earlier? 27.8 it should be. So we are getting a wrong result here. It is because either we made a mistake here. I think there is a mistake done somewhere here. There's a mistake. So 3 over 2 should be 5 over 2 is what somebody is saying. How far it is correct. So x to the power half x square is half plus 2 which is right. Yeah, no, we made a mistake. Yeah, it is 5/2. I think that is where the mistake is. Sorry for that, guys. Can you redo the calculation, sir? Okay, so I will put proper numbers to this to save time and then upload it the right way tomorrow. So for now, because I don't have the solution here, I don't want to waste time on this, but you can keep checking. It should give the same result. So is that fair enough? We'll move on, but you understood the procedure. Okay, let's go on with the next one. The two triangle areas are deleted from the rectangular area shown in the figure below. Calculate the moment of inertia of the remaining portion of the rectangular area about the x-axis. Right? Huh? Wait. Okay, just wait. Just hold on. Yep. The two triangular areas are deleted from the rectangular area shown in the figure below. Calculate the moment of inertia of the remaining portion of the rectangular area about the x-axis. So obviously, the full rectangle, you take it as area 1, and this area, say area 2, and this area as area 3. First, the moment of inertia of the full rectangle about the x-axis. So if you call the total moment of inertia as Ix area 1 minus Ix area 2 minus Ix area 3. This is what we need to do. So Ix1 is very simple, which is the moment of inertia of a rectangle about an axis passing through the base, which is 1 over 3 times p times h cubed, which you can see in the formula sheet. In this case, it is 1 over 3. The base length is 20 plus 10 plus 10 plus 20, which is 60, times the height is 5 plus 10, 15, 35, 45 plus 5, which is 50 cubed. Therefore, Ix1, the moment of inertia of a big rectangle, is 250, 100,000. Then A2, moment of inertia, if you want to get it on the x-axis, first we need to find the moment of inertia about an axis passing through its centroid and then parallel to the base. Then we should take this distance, which is the parallel distance, as let us say d2. So Ix2 is Ix2 about its own centroidal axis, which is let us say this is that axis Ix2 bar plus area 2 times the parallel distance squared. So centroid of a triangle about an axis passing through its centroid is 1 over 36 bh cubed. The b base length is 10 plus 10, which is 20, times the height of this triangle is 10, so 10 cubed, plus the area of the triangle is half 20 base times height 10 times this d2 is, as you can see, this distance is 5 and this extra distance is 1/3 of the height, which is 10, 1/3 of the height. So this becomes d2 is equal to 5 plus 1/3 of 10. But 1/3 of 10 is 3.333. Therefore, d2 is 8.3333. So 8.3333 square. When we simplify this, Ix2 is equal to 7499.9444 meter to the power 4, whatever it is. Let's not put the units here. Then Ix3 is Ix3 bar plus A3 times the parallel distance 3 square. Now Ix3 bar is about the moment of inertia of the small triangle. If you call that axis as x3 bar, the moment of inertia about that axis. For that, the base length is 20, the height is this 10, we know that. And then the parallel distance is, this is the parallel distance, d3. As you can see, d3 is equal to, up to this length is 5 plus 10 plus 20, which is 35, plus this extra length from here to here. The extra length will be from the apex to the centroid. The distance is 2/3 the height, which is 10. So d3 is equal to 35 plus 6.6667, which is 41 1.6667. And as you know, I x3 bar is 1 over 36 times the base is 20, the height is 10 cube, plus the area of the triangle is half base height times b3 is 41.6667 squared. After simplifying, I x3 is equal to 17 for 166.9444. So therefore, the total moment of inertia is equal to Ix1 minus Ix2 minus Ix, which is equal to 250 followed by 5 zeros or 4 zeros? 5 zeros, 4 zeros. 250, I'm getting only 4 zeros. Minus 7, 4, 9, 9, 9, 4, 4, minus 1, 7, 4, 1, 6, 6, 1, 9, 4, 4, 4, 5x is equal to 2, 3, 1, 8, 3, 3, 3, 1, 1. Okay, so that is the solution. Let me see if there are any pending questions here. Okay, Harshita Pandey, just wait. I will go to Harshita. Where is she? G H G H. Okay, where is? Let's see. Okay. Yep, the formula sheet will be given tomorrow. These answers will be on Blackboard. These are all done so many times. Why are you asking now, sir? So you don't know what I usually do. So it indicates that you're not connected to my class. Will these answers be posted online? I always post answers at the end of the session. You don't know this? I've done enough of friction questions. Review the class notes, sir. I can't do any more. Yep, I will solve the 2016 exam. I will go back to that now. Yeah, Mr. Bruce Cooper, wake up. Yeah, good man. Mr. Kyle, wake up, wake up. What is this? Wake up. Process, please. Okay, I'm going to 2016 exam now. For the remaining 20 minutes, I will solve the last two problems, which also incidentally covers the friction problem. So some of you are okay. Yeah, keep quiet now. Keep quiet. Okay, I have to get out of this. Let me request I have to stop sharing for a while. I will do that. Get out of this. We want all of the now, and then go to my computer. Um, 2017 teaching. Can you hear now? One or two say yes. Okay, okay, stop, 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 stop. Yep, you can, yep. So for this problem, you need to take these three as um, three areas. Then what is the question? Where is my, what is the moment of inertia about the about the x-axis? So for that, you write ix equal to ix1 minus ix2 minus ix3. I will not solve this whole problem. The final answer you will get for ix is 67.0 times 10 power, no, sorry, 54 times 10 power 6 millimeter to the power 4. That is the result you will be getting. By that form, in this problem, you need to solve. Determine the magnitude P of the vertical force required to lift the wheelbarrow shown in figure A6A free of the ground at point B. So free of the ground at point B means it will not have any reaction at point B. So what it means is if you take the free body diagram of this, which is um, you have the force P applied there, and the weight of this (110 kilograms times 9.81) acting there. And because it is a roller, we can take the reaction as vertical there. And the distances are given. We know these distances. This is 475 plus this is 200. Now, if you take sum of the moments about C equal to 0, we get minus P times 475 plus 525 plus 200 plus 110 times 9.81 is the rate times 200 equal to 0. From that, the P force that is needed is 179.85. It's a simple question, but it all depends on how you perceive the solution. Okay, then I will solve the ladder problem. Referring to figure A6B, determine the distance S to which the 90 kilogram painter can climb without causing the 4-meter ladder to slip at its lower end A. The top of the 15 kilogram ladder has a small roller, and at the ground, the coefficient of static friction is 0.25. Draw the free body diagram of the ladder and analyze for sliding at A. So it's a hint given for you. So it's just drawing the free body diagram and solving. The free body diagram looks something like this. So the angle, this angle is theta, and the person is climbing up to a certain distance w, which which we need to calculate. This is the weight of the person. Let's call it as wp, and this distance up to which he can climb is what we are actually after. The distance is s, and the remaining distance, the weight of the ladder itself will act from the center. Let's put it here. That is W of the ladder. But then that will be halfway through. So this length is 2 meters, and this length, the remaining length, is also 2 meters. And at the wall, a roller support is given, so there will be only a vertical reaction or a perpendicular reaction to the wall, NB. This is our point B, and this is our point A. But at A, it will give you a normal reaction, NA, and there must be a frictional reaction, otherwise the person will fall and die. So if it is falling, it will slide to the left, and so the frictional resistance should be in the opposite direction at A like this. That is it. These are the forces. This is the ladder when it is just about to slide. When he gradually climbs at a particular distance, it reaches its limiting friction condition and starts sliding. And therefore, at that point, motion is impending, but still it is in static equilibrium. So we can use the static equilibrium conditions. Let us calculate some essential items. Weight of the ladder is equal to 15 kilograms times 9.81, which is 147.15 newtons. And weight of the person is 90 kilos times 9.81, which is 882.9 meters. Theta is tan inverse oh, we don't have that vertical, so we can't use tan. We can use cos. Cos inverse adjacent divided by diagonal, which is 4 meters. So therefore, theta is 67.98 degrees. The friction at A for limiting case would have reached mu static times normal reaction. Therefore, the friction force at A is equal to 0.25 times the normal reaction at A. Let us start writing the equations. Sigma Fy equal to 0 in this case will give us normal reaction Na minus 490.5 minus 147.15. These are weight of the layer minus and weight of the person equal to 0. From this, the normal reaction is equal to 8. Wait, what is this? I made a mistake here. The weight of the person is 882.9. So Na is equal to 1030. So that is the normal reaction at A. Let's take the sum of the moments about point B equal to 0. Sigma MB equal to 0. Carefully follow this equation. Minus NA times 1.5. This is the clockwise movement of Na about point B, which is taken as negative, plus Fa times 4 times sine 67.9 plus WP times 4 minus S times cos 67.98 plus WL times 2 times cos 67.9 equal to 0. Let me explain this equation once. If you look at that diagram, the movement of Na about point A is, I will put some marks here. Na times 1.5, which is a clockwise movement. So we took that as Na times 1.5 negative. Okay, I will undo that part. And the second one is Fa. The moment of Fa is here. Its moment about point B is Fa times that distance. And that distance is, this is 4 and this angle is theta. So opposite divided by diagonal 4 is sine theta. Therefore, this opposite is equal to 4 times sine theta. So Fa times 4 times sine of that angle. That is the moment of Fa. And this is counterclockwise movement. So taken as positive. Okay, next. WP is here. WP moment about B is WP times that distance. This distance is, this length is S and this total length is 4. So the remaining length here is 4 minus S. So 4 minus S cos of that angle is that distance. And that movement is counterclockwise too, so taken as positive. So that is this quantity. And the WL part, WL is here, and its distance from here is, this is half the ratio, so this is 2, and this angle is theta. So 2 cos theta is its distance, and it is also counterclockwise movement, so taken as positive. I will put that properly there. So WL times 2 times cos 67 equal to 0. So now I'm just substituting what these quantities are. Therefore, NA is minus 10, 30. That's what, but FA is 0.25 times NA, which is 1030 times 4, plus WP is 882.9 times 4 minus this times cos 67.98 plus WL is 147.15 times 2 times cos 67.98 equal to 0. Now if you solve this equation, so you will finally get AS as equal to 2.55 meters, because that is the only unknown quantity in that equation. I'll leave the rest of it for you to solve at home. Now, let me see what's happening around the room. Okay. Yeah, this is the method. If you find a better method, do it. It's no problem. So somebody wants brackets. So if you want brackets, we'll put brackets. What is there? This is one moment. This is another moment. This is another moment. And this is another one. So this is one. This is another one. This is another one. This is the other one. And after simplification, this is the answer. So if you can get a solution simpler than this, you can go ahead and do that. All right. I will stop it here unless you have any specific questions. I will give you the first question we can solve like this. Because we are running out of time, I will send you the trust question as a ready solution. You follow that solution. I will copy that solution in the trust problem. I will include the solution and upload the solved version of the online session. And for all the other questions, so you will have to prepare for friction, trusses, moment of inertia, and centroid for the test tomorrow. And I've done my part. And you can't learn everything in this one session if you're not in the classes and not doing the work regularly. This is not going to help. But I've said this a number of times. So any other real question? All right. I'm going to upload these things now as you are talking, but where are you, Troy? Tomorrow is the test in the class. So I'm going to as you are here, I'm going to upload this